From watching Robust and Jamie, skin day,
Straight mo ko to. Gusto 5. Sila magyapon, tanin nila sa matakan sa akong first year. Ganun. Ah, can you see my screen? I was reading some messages sa Messenger. May 3 na galing na nagsulod gina. Okay. So, straight kita no, subong nga Monday. Grabe ba? Sige. Tani nila ka mo matakan sa kong tsura. Or I can hide my cam na lang. Okay. So by the way, na-send ko na ang recorded discussion kag-ina sa computer-aided drafting na subject natin. So today we will be discussing the our first module sa sa computer programming naman. Okay? So we will discuss the history, some sort of history of computers. Okay? And by the way, I'm not sure if you all have account na sa LMS. So you have your seat work there number 1 later on. Screenshot ko na lang later on para sa mga wala pa account sa LMS. Okay, so if you think physics, math, and chemistry, ginabuli ka mo as a student, no? More on equations, formulas, mga theory, mas hambal nila, mas malala pag kung ang programming. Ay, dalang tabi ko. Okay, so going back, so if you think no na mas grabe ang physics, math, kag chemistry. So pag-abot sa programming, mas grabe pagid siya. Mas hyper pagid. Okay? So lang taon ta kung ngaman. Let's study anong meron dito sa programming na to. So there are different types of programming languages. But in our case, which is very important na programming language, we will be focusing on Python. Okay, so Python programming language. So it is very easy. I hope so for you guys. And very user-friendly ang iyang interface. Yan. So unlike sa time namon, which is we study the Java programming language, wherein hindi pa popular, no? Hindi pa popular ang Python. Because in today's technology trends, so Python programming language is mainly used for IoT, or more on automation and artificial intelligence, and basically machine learning language, no? Okay. So according to Michelle Minkoff and Heather Billings, I will minimize my thumbnail muna. Kung makita yung full screen ng discussion. Ayan. So meron tayong 5 things, no? 5 things beginner programmers need to know. Kailangan malaman. So first here, don't be afraid to ask for help. So guys, Google is your friend. So try to ask Google if you need something, or try to ask me if you need help, or try to ask your classmate. Baka alam nila. Don't try generally learn the code. Ito yung pangalawa. So pick a project you like and try to emulate it. Okay, so this is siguro pagdating sa sa later part, because you will have your finals, which is disclose ko na lang sa inyo. Your finals will be a certain program. Okay, so written by you, of course. So it might be a group, it might be individual. Tingnan natin. And third, don't be afraid of failure. So aim for it. So take note that you won't kill anyone. Okay, so don't be afraid of failure. Failure is a part of success. Ika nga. Fourth, have enough confidence to believe in yourself. Of course, syempre. But enough humility to know you don't know everything. Okay? Then the last one is treat programming like a new beat. Okay? Parang challenge lang siya. Know where to find the answers to the questions you will arise. Okay, so yan yung kailangan nyo malaman according to Michelle Minkoff and Heather Billings. Okay. I post, ewan ko kung sino naka-follow sa Facebook sa akin, but I post 2 link. Yung una is isang programmer na sinibak sa trabaho after 6 years dahil nakalimutan niya na kung paano mag-program, paano mag-code. And meron din akong isang link na naman na pinost na isang programmer na nag-automate ng kanyang trabaho, tapos kumikita pa rin, hindi siya nasibak. Okay? So dito muna tayo sa first. Programmer fired after 6 years, he realizes he doesn't know how to code. So ito yung story na, by the way, this post was taken in this link. Okay. So this was a issue last 2016. Okay, so sinibak siya sa trabaho kasi nalaman nung inaudit yung kumpanya nila, yung IT company nila, nalaman ng isang auditor na pinoprogram niya, yung trabaho niya is pinogram niya lang, automated. So yung ginagawa niya lang for 6 years, naglalaro lang ng computer games. Nagli-League of Legends lang siya. Buong araw. Diba? Buong araw. Siguro chine-check niya lang kung gumagana yung code niya. Tapos yun lang. And then 6 years. So siguro hindi niya na na-practice yung coding skills niya. So syempre, laro lang siya ng laro sa niya, sa desk niya, sa trabaho niya. Then hindi na expect na ipa-fire siya. Pero okay naman sa kanya as I read the article. So may naipon naman siya. I think nakapag siya, physically fit kasi nag-gym siya habang nagtatrabaho or habang nasa trabaho. Okay? So he let the computer do its job by programming a code and then do the automation. While in this article, this new article, so this was taken this year, so January 2022. Ito naman yung ginawa niya, ginawa niyang program na nagamit niya during the pandemic. Okay? Ito yung time na sinabihan sila ng kanyang employer na mag-work from home sila. Okay? So ito, hindi siya sinipa. Hindi siya sinipa sa trabaho. Pero at saka nag-earn pa rin siya ng kanyang sweldo. Di ba? So anong pinagkaiba nila? So try to think of that. Okay, so first topic, we will discuss the two fundamental ideas of computer science, which is the algorithms and information processing. Okay, so ito yung dalawang fundamental ideas of computer science. So which is the algorithm and information processing. Okay. First, let us talk about algorithm. So people computed long before the invention of modern computing devices, and many continue to use computing devices that we might consider primitive. For example, consider how merchants and made change for customers in marketplaces before the existence of credit cards, pocket calculators, or mga cash registers or mga POS, no? Point of sales machines. So making change can be a complex activity. So it probably took you some time to learn how to do it, and it takes some mental effort to get it right every time. So let's consider what's involved in this process. So according to one method, let's say bibili ka sa isang hardware, or let's say bibili ka sa isang computer shop. The first step is to compute the difference between the purchase price and the amount of money that customers give the merchant, or that the customer gives the merchant. Diba? So ano yung result? So the result of this calculation is the total amount that the merchant must return to the purchaser. Okay? Yan yung first step. For example, if you buy a dozen eggs at the farmer's market for 85 pesos and 50 centavos, and you will give the farmer 100 peso bill. So she would return 14 pesos and 50 cents to you. So to produce this amount, so kabaliktaran. So the merchant selects the appropriate coins and the bills. So tingnan niya muna. And then kukunin niya yung i-add niya sa 85.5 para maging buo. Tapos yun yung isusukli niya. Okay? Baliktad siya. Instead na 100 minus 85.5, so si merchant magkukuha ng mga coins at bills para mabuo yung 100 pesos from 85.5 pesos. Okay? Yan yung una. So according to another method, the merchant starts with the purchase price and goes toward the amount given. Yan. So first coins are selected to bring the price to the next amount. So in this case, dalawang 25 cents, which makes 50 cents. Then peso are selected to bring the price to the next 10 pesos amount. So that is 4 pesos. And then in this case, a 10 pesos coin completes the transaction. So as you can see, there can be many possible methods or algorithms that solve the same problem. And the choice of the best one is a skill you will acquire with practice. So it depends on you. Okay? So it depends on you now. So diriya, sa iyang method, nag-isip siya from 85.5 going to 100 pesos. So nag-start siya sa 25 cents. Duwa ka 25 cents para mabuo ang piso. So that is 0.5 now. And then nag-count siya from next to 10 pesos amount. For this case, 4 pesos. Up to makuha niya ang 14.5 na change niya. Okay? So another example. So for example, the following list of steps describe the process of subtracting two numbers using a pencil and paper. So ano yung first step natin? Diba? Isusulat natin yung dalawang numbers with the larger number above, the smaller number below. And their digits aligned in columns from right to left. Diba yan yung pagsasubtract natin. Then step 2, assume that you will start with the rightmost column. So dito tayo sa bandang kanan simula. And work your way papuntang kaliwa. Yan yung basic na pag-subtract natin. So write down the difference between the two digits in the next current column line or column of digits, borrowing a 1 from the top number's next column to the left if necessary. So next step, if there is no next column to the left, so mag-stop tayo. Otherwise, mag-move tayo sa next column to the left. And go back to step 3, which is subtract again and subtract. Okay. So if the computing agent, in this case, human being, tayo, sarili natin. Diba? Tayo yung computing agent. Follows each of these simple steps correctly, the entire process results in a correct solution to a given problem. So we assume in step 3 that the agent already knows how to compute the difference between the two digits in any given column. And then, borrow natin if necessary. So to make change, most people can select a combination of coins and bills that represents the correct change amount without any manual aids. Diba? Tayo magkakount tayo, let's say, nagsakay ka sa tricycle. O, pamasahe mo is 15 pesos. Pero binigay mo is 20 peso bill. Diba? So automatically, malalaman mo agad yung sukli mo. That is 5 pesos. But the mental calculations involved can still be described in a manner similar to the preceding steps. And we can resort to writing them down on paper if there is a dispute about the correctness of the change. So ano yung sequence of steps natin? So the sequence of steps that describes each of these computational processes is what we call algorithm. Okay? Sequence of steps, algorithm yan. Informally, an algorithm is like a recipe. Okay? Parang recipe siya. It provides a set of instructions that tells us how to do something, which such as make change, make bread or bake bread, or put together a piece of furniture. Parang instructional manual siya. Okay? More precisely, an algorithm describes a process that ends with a solution to a problem. Okay? Describes a process that ends with a solution to a problem. The algorithm is also one of the fundamental ideas of computer science. And an algorithm has the following features. First, an algorithm consists of a finite number of instructions. When you say finite, meaning limited siya. Okay? Each individual instruction in an algorithm is well defined, and an algorithm describes a process that eventually halts after arriving at a solution to a problem. So when you say halts, pag nakuha niya na yung solution sa problem niya, automatically it stops. Yan lang yan. Okay? An algorithm also solves a general class of problems. Yan. So creating a list of steps that describes how to make change might not seem like a major accomplishment to you, but the ability to break a task down into its component parts is one of the main jobs of a computer programmer or a computer programmer. So once we write an algorithm to describe a particular type of computation, we can build a machine to do the computing. And so put another way, if we can develop an algorithm to solve a problem, we can automate the task of solving the problem. Which is, yun yung ginawa ng dalawang programmer na yun. Yung isa, sinibak sa trabaho. Yung isa naman, eh may trabaho pa rin, kumikita pa rin. Okay? So you might not feel compelled to write a computer program to automate the task of making change because you can probably already make change yourself fairly easily. But suppose you needed to do a more complicated task, such as sorting a list of 100 names, let's say 100 student names, isosort mo isa-isa. So in that case, a computer program would be very handy. Isang pindot lang yan, sorted na agad. Yan. So computers can be designed to run a small set of algorithms for performing specialized tasks such as operating a microwave oven. But we can also build computers like the one on your desktop that are capable of performing a task described by any algorithm. So these computers are truly general purpose problem solving machines, and they are unlike any machines we have ever built before. So subong may nakita sing ginatawag na supercomputer. If you have heard of it, may nakita ginatawag na supercomputers. And they have formed the basis of the completely new world in which we live. Since human beings first learned to write several thousand years ago, they have processed information. And information itself has taken many forms of, or in its history. Okay? So dito na tayo sa information processing. Okay? So from the marks impressed in clay tablets in ancient Mesopotamia to the first written text in ancient Greece, to printed words in the books, newspapers, and magazines mass-produced since the European Renaissance, to the abstract symbols of modern mathematics and science used during the past 350 years. Only recently, however, have human beings developed the capacity to automate the processing of information by building computers. So in the modern world of computers, information is also commonly referred to as data. But what is information? Ano yung information? Like mathematical calculations, information processing can be described with algorithms. Partner sila. In our earlier example of making change, the subtraction steps involve manipulating symbols used to represent numbers and money. In carrying out the instruction naman of any algorithm, a computing agent manipulates information. And the computing agent starts with some given information, which is also known as the input, transforms this information according to well-defined rules, and produces new information known as the output. Okay? So from input, then process the information, and then produces the new information known as the output. So it is important to recognize that the algorithms that describes information processing can also be represented as information. So computer scientists have been able to represent algorithms in a form that can be executed effectively and efficiently by machines. They have also designed real machines, which we call electronic digital computers, which are capable of executing algorithms. So take note, your cell phone is a computer. Okay? Your cellular phone, your smartphone is a computer. Okay? So computer scientists more recently discovered how to represent many other things such as images, music, human speech, and video as information. Many of the media and communication devices that we now take for granted would be impossible without this new kind of information processing. So let's take a look at the structure of a modern computer system. Tingnan natin. So a modern computer system usually consists of hardware and software. Ano yung mga hardware? So hardware consists of physical devices required to execute algorithms. And software naman is the set of these algorithms, represented as programs, in particular, programming languages. In the discussion that follows, we focus on the hardware and software found in a typical desktop computer systems, although similar components are also found in other computer systems, such as handheld devices, which are which is your cell phones or smartphones, and ATMs, or automatic teller machines. So computer hardware. So the basic computer hardware components of a computer are memory, a central processing unit or the CPU, and a set of input or output devices as shown in figure 1-1. Ito. Okay? So ano yung mga input devices? Ano yung mga output devices? Input devices, examples. Ito yung ginagamit natin para makapag-input tayo sa computer. So mostly, a mouse, a keyboard. How about output devices? Maybe speaker, a headset, a headphone, or a printer para makapag-print, or that is the output device. Okay, yun na yun. So human users primarily interact with the input and output devices. So the input devices include a keyboard, a mouse, a trackpad, a microphone, and a touch screen. So common output devices include a monitor and speakers. So computers can also communicate with the external world through various ports that connect them to networks and to other devices such as smartphones and digital cameras. Diba kung i-connect natin itong cellphone, so we use the data cable from the Type-C or micro USB to the USB ports ng ating computer. Okay. So the purpose of most input devices is to convert information that human beings deal with, such as text, images, and sounds, into information for computational processing. So the purpose of most output devices is to convert the result of this processing back to human usable form. Because take note that the computer don't understand English. It only understands 1 and 0. Okay? 1 and 0 lang yung naiintindihan nila. Hindi sila nakakaintindi ng English word, grammar, etc. Alam lang nila is 1 and 0. Okay? So computer memory is set up to represent and store information in electronic form. So specifically, information is stored as patterns of binary digits, ones and zeros. Okay, ito yung tinutukoy ko. Binary digits, which is 1 and 0. So to understand how this works, consider a basic device such as a light switch, which can only be in one of two states, that is on or off. Meaning, when you say 1, on siya. Pag 0, off siya. Now suppose there is a bank of switches that control 16 small lights in a row. Meaning, may 16 switches din siya. By turning the switches off or on, we can represent any pattern of 16 binary digits as patterns of lights that are on or off. As we will see later, computer scientists have discovered how to represent any information, including text, images, and sound in binary form. Okay, so let's say your name is Kenneth. So there is a substitute, or there is a representation of binary form in the word Kenneth. Okay, so later on we will discuss on the ASCII. Yan. So ito yung representation. So now suppose there are 8 of these groups of 16 lights. Okay, 16 lights yan. Pero meron tayong cell 8 or G8 groups. No? So we can select any group of lights and examine or change the state of each light within that collection. So we have just developed a tiny model of computer memory. So the memory has 8 cells, each of which can store 16 bits of binary information, and a diagram of this model in which the memory cells are filled with binary digits, that is ones and zeros. And so the memory is also sometimes called primary or internal, or most commonly known as random access memory or RAM. Okay? Random access memory or what we call RAM. Hindi yung inumin na RAM ha. Hindi rin yung RAM na yung sa lata na RAM. So the information stored in memory can represent any type of data, such as numbers, text, images, or sound, or the instructions of a program. We can also store in memory an algorithm encoded as binary instruction for the computer. So once the information is stored in memory, we typically want to do something with it. That is, we want to process it. Okay, once nga makakolect na kita sa information nga na-store na nato sa memory, what we will do is we will process it. So the part of computer that is responsible for processing data is what we call the central processing unit or the CPU. Okay, so this device, which is also sometimes called a processor, consists of electronic switches arranged to perform simple logical, arithmetic, and control operations. Okay, so parang marami siyang micro switches sa loob niyan. So the CPU executes an algorithm by fetching its binary instructions from memory, decoding them, and executing them. So executing an instruction might involve fetching other binary information, which is the data, from memory as well. So the processor can locate data in a computer's primary memory very quickly. However, this data exists only as long as electric power comes into the computer. Meaning, yung RAM mo or yung random access memory mo, mag-work lang siya at mag-store lang siya ng data pag merong power. Pag walang power, yung digital data mo doon or yung binary data mo doon mawawala. Okay? So if the power fails or is turned off, the data in primary memory are lost. So clearly, a more permanent type of memory is needed to preserve data. And this more permanent type of memory is what we call external or secondary memory. And it comes in several forms. So we have magnetic storage media, okay, or the tapes, and hard disks. Okay, so it allows bit patterns to be stored as patterns on a magnetic field. Then we have semiconductor storage media such as flash memory stick or what we call the USB natin, USB drive, flash drive, which perform much the same function with a different technology as do as in optical storage media such as CDs and DVDs. So some of these secondary storage media can hold much larger quantities of information than the internal memory of a computer. Okay? Magkaiba ang magkaibang primary at secondary memory. Sa primary memory, temporary lang yung data diyan. While sa secondary, permanent. Unless deleted. Okay, unless din-delete siya. Or na-wipe. Yan. So you have learned that a computer is a general purpose problem-solving machine. To solve any computable problem, a computer must be capable of executing any algorithm. Because it is impossible to anticipate all of the problems for which there are algorithmic solutions, there is no way to hardwire all potential algorithms into a computer's hardware. Instead, we build some basic operations into hardware's processor and require any algorithm to use them. And the algorithms are converted to binary form and then loaded with their data into the computer's memory. Then the processor can then execute the algorithm's instructions by running the hardware's more basic operations, which is ones and zero or on and off. Yun lang yun. Yan lang yung alam ng computer natin. 1, 0, on, off. So any programs that are stored in memory, so that they can be executed later is what we call software. Yan. So ano example ng mga software? AutoCAD application, AutoCAD software. Yan yung software na example. Okay? So a program stored in computer memory must be represented in binary digits, which is also known as machine code. So loading machine code into computer memory, one digit at a time would be a tedious. Medyo ano siya, maoti siya obrahon. So error prone task for human beings. And it would be convenient if we could automate these processes to get it right every time. So for this reason, computer scientists have developed another program which is called loader. This is to perform the tasks. Okay, so a loader takes a set of machine language instructions as input and loads them into the appropriate memory allocations kung saan cell siya ilalagay sa memory natin. When the loader is finished, the machine language program is ready to execute. So obviously, the loader cannot load itself into memory. So this is one of those algorithms that must be hardwired into the computer. That's why meron tayong software na tinatawag. So now that a loader exists, we can load and execute other programs that make the development, execution, and management of programs easier. So this type of software is what we call system software. And the most important example of system software is a computer's operating system. Okay, so ano yung mga operating system natin? We have Linux, we have Apple's Mac OS, we have Microsoft's Windows. Yan. So an operating system is responsible for managing and scheduling several concurrently running programs. So it also manages the computer's memory, including the external storage, and manages communications between the CPU, the input-output devices, and other computers on a network. An important part of any operating system is its file system, okay, which allows human users to organize their data and programs in a permanent storage or for the secondary storage. Another important function of an operating system is to provide user interfaces. That is, ways for the human user to interact with computer's software. Okay, so a terminal-based interface accepts input from the keyboard and displays text output on a monitor screen. So we have a graphical user interface, or the GUI, which organizes the monitor screen around the metaphor of a desktop, with windows containing icons for folders, files, and applications. So during the siguro mga ano naman, during wala pa na-invent ang GUI, no? Ang graphic user interface. Mostly na ginagamit nila na computer is terminal-based interface. So wala silang mouse that time, keyboard lang tsaka monitor. Yan. This type of user interface allows the user to manipulate images with a pointing device such as a mouse. A touch screen interface naman supports more direct manipulation of these visual elements with gestures such as pinches and swipes of the user's fingers in case sa aton nga smartphone. Diba? So ano naman yung operating systems ng smartphone natin? It might be Apple,
Android, sir.
Android. Diba? So devices that respond verbally and in other ways to verbal commands are also becoming widespread. Ito, another major type of software is what we call application software. Ano yung una kanina? System software. Itong pangalawa, applications software. Dito na yung mga application na like AutoCAD, like Mozilla Firefox, like Google Chrome. Yan. Like Microsoft Office. Yan. Yan yung tinatawag natin application software or simply apps. So an application is a program that is designed for a specific task such as editing a document, or displaying a web page. Applications include web browsers, word processors, spreadsheets or Excel, database managers, graphic design packages or Photoshop, music production systems, and games like Garena, League of Legends, among millions of others. So as you begin learning to write computer programs, you will focus on writing simple applications. Okay? Like, ano mga simple applications? Like calculator. A calculator written in Python programming language. Simple lang. As you have learned, computer hardware can execute only instructions that are written in binary form. That is in machine language. Okay? So how about sa computer software naman? So writing a machine language program, however, would be an extremely tedious error-prone task. So to ease the process of writing programs or writing computer programs, computer scientists have developed naman high-level programming languages. This is for expressing algorithms. And these languages resemble English and allow the author to express algorithms in a form that other people can understand. So, tao sa tao lang. Okay? So, meron tayo dito. A programmer typically starts by writing high-level language statements in a text editor. It might be a notepad. It might be a text Notepad++ na software, or any text editor. Okay? So the programmer then runs another program called a translator to convert the high-level program code into executable code, because it is possible for a programmer to make grammatically mistakes even when writing high-level code. So the translator checks for syntax errors before it completes the translation processes. Kung sa tao, ang ato niya nga gina-check is the grammar, ang sa computer naman niya, ang gina-check niya is ang algorithm. Okay? Ang algorithms ang code kung may error siya. If it detects any of these errors, the translator alerts the programmer via error messages. Like, kulang ka sang semicolon sa meaning line sa imo code. Yan. Or, this command sa imo code does not exist. Yan. Or, kulang ka sang close parenthesis. Or kulang ka sang semicolon or quotation sa imo nga code in this line sa imo nga text. Yan. So the programmer then has to revise the program. If the translation process succeeds without a syntax error, then the program can be executed by the runtime system. So the runtime system might execute the program directly on the hardware or run yet another program called an interpreter or virtual machine to execute the program. Yan. So let's talk about a not so brief history of computing systems. So alam na natin yung software and hardware sa computer. Then nalaman din natin yung mga what we call algorithm. And mga sequences natin. So a not so brief history of computing systems. Tingnan natin. So if you take a look, we have these approximate dates here. So that is before 1800. So the major developments here, so mostly mga mathematicians, no? So abacus. Yeah? So abacus was used as a calculating aid before 1800s. And then the first mechanical calculator, which is built by Pascal and Leibniz, were developed here during this time. And in 19th century, we have Jacquard's loom. And then we have the Babbage analytical engine, the Bose system of logic, and the Hollerith punch cards machine. Then 1930s, we have here the Alan Turing's kay Turing publishes results on compatibility. We have also Shannon's theory of information and digital switching, which is evolved from analog to digital communications. Then 1940s, we have our first electronic digital computers. 1950s, the first symbolic programming languages. Then transistors make computers smaller, faster, more durable, and less expensive. Then emergence of data processing applications. Then 1960s naman to 1975. Yan. Then sa 1975, so we have here the first microcomputer and mass-produced personal computers. Yan, during this time, no? Then we also have graphic user interfaces na. Yung mga GUI na kita. Then of course, networks and the internet. Yan. Diyan na-discover yung international network natin. Then 1990 to 2000, so nausod dito yung floppy drive, yung diskette. If you remember, still remember, before the USB drive na storage, we use the floppy drive. Multimedia applications, images from camera na na may film pa. Ngayon digital na. Wala na nga camera yung iba eh. Cellphone na lang, di ba? Then sounds and video. Yeah. And of course, we have the World Wide Web, web applications, and e-commerce. Then, dyan na, lumabas na yung laptop. Then, 2000 to present, so wireless na, smartphones, mobile applications, and computer embedded network in an enormous variety of cars. Diba? Meron na kung sino man yung may sasakyan dyan. Household appliance. Diba? Meron na tayong AI. And IoT. Yan. Social networking, big data, finance and commerce. Then digital streaming of music and video, Spotify, Netflix, name it. Diba? So, ito na yun. Before electronic digital computers. And excuse mo na. Okay. So we will continue. So in the 17th century, so the French mathematician Blaise Pascal, so this was 1923, no? So 1623 to 1662. Grabe. So built one of the first mechanical devices to automate the process of addition. Okay. So si Blaise Pascal yung nagsimula naka-invento ng addition na to automatically. Okay. So addition operation was embedded in the configuration of gears within the machine. So the user entered two numbers to be added by rotating some wheels. Then the sum or output number appeared on another rotating wheel. So the German mathematician Gottfried Wilhelm Leibniz built another mechanical calculator that included another arithmetic functions such as multiplications. Leibniz, who with Newton, also invented calculus. So itong tatlong to, sila may kasalanan kung bakit meron tayong calculus. Okay? So sino ba sa kanila? So went on to propose the idea of computing with symbols as one of our most basic and general intellectual activities. So he argued for a universal language in which one could solve any problem by calculating. So si Leibniz talaga, no? Tsaka si Newton. Ba't kasi inimbento pa nila yung calculus? Bakit nga ba? Diba? So early in the 19th century naman, so the French engineer Joseph Marie Jacquard designed and constructed a machine that automated the process of weaving. Yan, ano ba yung weaving? Search nyo na lang kung ano yung weaving. Until then, each row in a weaving pattern had to be set up by hand, a quite tedious, error-prone process. Ito ata yung parang sewing machine, no? Parang sewing machine. So, Jacquard's loom was designed to accept input in a set of punch cards. So may punch cards siya. And each card described a row in a pattern of cloth. Tama. Cloth. So although it was still an entirely mechanical device, so Jacquard's loom possessed something that previous device had lacked. So that is the ability to execute an algorithm automatically. Yan.
Sir,
Yan yung
sir, siya nga last name din kuha ang term nga loom. Mag-weave. Excuse me. Mag-weave ka bala, sir, sa cloth.
Maybe. Wala ko idea. But base sa iyagin man din point ang term. Kaya siya naka-invent mo sang it's what we call the Jacquard's loom. Yan. Then we have the British mathematician. So Charles Babbage. Okay, so took the concept of a programmable computer for a step further by designing a model of a machine that conceptually bore a striking resemblance of a modern general purpose computer. So he's also considered as father of computer. Tama ba? Father of computer, si Charles Babbage. And conceived his machine, which he called an analytical engine. And as a mechanical device, so his design called for 4 functional parts. So we have a mill to perform arithmetic operations, a store to hold data and a program, an operator to run the instructions from punch cards, and an output to produce the results on punch cards. So sadly, Babbage computer was never built. So hindi nagawa physically yung computer niya. So the project perished for lack of funds near the time when Babbage himself passed away. And the last 2 decades of 19th century, so a US Census Bureau statistician named Herman Hollerith developed a machine that automated data processing for the US Census. So his machine, which had the same component parts as Babbage analytical engine, simply accepted a set of punch cards as input and then tallied and sorted the cards. So his machine greatly shortened the time it took to produce statistical results on the US population. And government and business organizations seeking to automate their data processing quickly adopted Hollerith's punch card machines. And then he was also one of the founders of a company that eventually became IBM, or the International Business Machines. So ito yun. Yan. Also in the 19th century, the British secondary school teacher, so George Boole, so dito na yung na-develop yung system of logic natin, which is true and false. And a set of primitive operations which is and, or, and not. Yan. So dito nagsimula yung Android. Android. Boolean logic eventually became the basis for designing the electronic circuitry to process binary information. So a half a century later, in the 1930s, British mathematician Alan Turing explored the theoretical foundations and limits of algorithms and computation. So Turing's essential contributions were to develop the concept of a universal machine that could be specialized to solve any computable problems and to demonstrate that some problems are unsolvable by computers. So I think may may documentary film si Alan Turing. So he is one of the he is considered as one of the one who cracked the Enigma code of the German during the World War. Okay, so try to watch that one. Very very inspiring movie. Okay, then in the late 1930s, so we have the Claude Shannon. So a mathematician and electrical engineer at MIT wrote a classic paper titled Symbolic Analysis of Relay and Switching Circuits. So this paper showed how operations and information in other systems such as arithmetic could be reduced to Boolean logic and then to hardware. So for example, if the Boolean values are true and false were written as binary digits 1 and 0. So one could write a sequence of logical operations that computes the sum of two strings of binary digits. So later on sa digital electronics you siguro, the subject, second year or third year, you will learn about the truth table of these digits, ones and zeros. Okay, all that was required to build an electronic digital computer was the ability to represent binary digits as on or off switches and to represent the logical operations in other circuitry. Yan. So the needs of the combatants in World War II pushed the development of computer hardware to high gear. So several teams of scientists and engineers in the United States, England, and Germany independently created the first generation of general-purpose digital electronic computers during the 1940s. So all of these scientists and engineers used Shannon's innovation of expressing binary digits and logical operations in terms of electronic switching devices. So among these groups was at Harvard University under the direction of Howard Aiken. So their computer, which is called Mark I, became operational in 1944 and did mathematical work for the US Navy during the war. So the Mark I also was considered as an electromechanical device because it used a combination of magnets, relays, and gears to store and process data. So hindi pa uso dati yung I think hindi pa uso dati yung mga radar sa navigational aids natin. So nag-ano lang sila nagde-depend sila sa kanilang equipment or machine at the time. Okay, so this is the first electronic computers. Ayan. So manual, may manual pa rin, of course. So another team under J. Presper Eckert and John Mackley at the University of Pennsylvania produces a computer called the ENIAC. Yan, ito yung electronic numerical integrator and calculator. So this was used in the artillery of the US Army toward the end of the war. So ENIAC used entirely electronic components. It was almost 1,000 times faster than the Mark I. Then we have two other electronic digital computers. That is ABC, no? Atanasoff Berry computer and the Clifford Berry. So it was built, no, by John Atanasoff and Clifford Berry at Iowa State University in 1942. And the second one was Colossus. No? It was constructed naman by a group working under Alan Turing in England in 1943. So the ABC was created to solve systems of simulations, simultaneous linear equations, although the ABC's function was much narrower than the ENIAC. Okay, and ABC is the first regarded as the first electronic digital computer. Then the Colossus naman, its existence have been top secret until recently, was used to crack the powerful German Enigma code during the war. So I think the documentary film is titled The Imitation Game. So try to search that one, The Imitation Game, and watch the documentary film. So isa dyan si Alan Turing. They're the one who cracked the Enigma code of Germany during the war. Okay? Ito yun. Ano to? Ano napapansin nyo? Mostly na mostly babae, no? Bakit kaya mga babae?
Sir, may ara ko nabasa dati ang first nga programmer babae, sir.
Tama. Sino?
Nalipat na ko siya name pero wala ko natandaan ang first nga programmer babae. Kag mga babae sila ang ga-work dati sa mga electronics kay mga digital sa mga computer puro mga women.
So babae din man ang naging first na naging programmer na. Pero yung mga inventor ng machine, mga lalaki. Diba? So ito, I think this is Colossus. This is the Colossus. Okay. Ito yung Colossus na program or na computer, no? So, tingnan nyo. Compare nyo siya sa laptop na ginagamit nyo ngayon, sa cellphone na ginagamit nyo ngayon. Diba? The first electronic digital computer, sometimes called mainframe computers. So it consisted of vacuum tubes. Kung makikita nyo yung mga vacuum tubes, oh. Yan. Mga vacuum tubes yan. Taas. Okay. Wires and plugs and filled entire rooms. So although they were much faster than people at computing, so by our own current standards, they were extraordinarily slow and prone to breakdown. Moreover, the early computers were extremely difficult to program. Okay. So to enter or modify a program, a team of workers had to arrange or rearrange the connections among the vacuum tubes by unplugging and replugging the wires. So ito yung ginawa nila dati. Yan. Yan yung ginagawa nila. Unplugging and replugging of wires. Yan. So each program was loaded by literally hardwiring it into the computer. With thousands of wires involved, it was easy to make a mistake. Okay, so the memory of these first computers stored only data, not the program that processed the data. So as we have seen, the idea of stored program first appeared 100 years earlier in Jacquard's Loom and in Babbage's design for the analytical engine. But in 1946, John von Neumann realized that the instructions of the programs could also be stored in binary form in an electronic digital computer's memory. So dira na develop ang RAM. Okay? So his research group at Princeton developed one of the first modern stored program computers. Although the size, speed, and applications of computers have changed dramatically since those early days, the basic architecture and design of electronic digital computer have remained remarkably stable. So the typical computer user now runs many programs made up of millions of lines of code that performs what would have seemed like magical tasks 30 or 40 years ago. But the first digital electronic computers had no software as we think of it today. The machine code for a few relatively simple and small applications had to be loaded by hand. As the demand for larger and more complex applications grew, so did the need for tools to expedite the programming processes. So may mga programming language na nag-evolve because of technologies mga nag-evolve. Diba? So let's say a programming language that is used to create a software for Android and to create also for iOS. So there are different programming software, programming processes. Yan. So in the early 1950s, computer scientists realized that a symbolic notation could be used instead of machine code. And the first assembly language appeared. Yan. Ano yun? So the programmers would enter mnemonic codes for operations such as add and output, and for data variables such as salary and rate. And then, the key punch machine, meron tayong key punch machine na mag-i-stroke lang tayo ng keystroke lang sa punch sa set of holes in a small card for each instruction. So parang siya, parang sa loto. Yung sa loto na nagmamark ka ng number. Yan, parang ganyan din. So the programmers then carried their stacks of cards to a system operator who placed them in a device called a card reader. Okay, so dito, by punch, pinapuncher nila. Binubutasan nila. Pero dun sa PCSO sa Lotto, minamark lang, di ba? Yun. Parang ganun din. So the device is translated the holes into cards patterns to the computer's memory. Then the program called an assembler then translated the application's programs in memory para maging machine code siya. And then, sa kanya i-execute yung program. Okay. So programming in assembly language was a definite improvement over programming in machine code. The symbolic notation used in assembly languages was easier for people to read and understand. And another advantage was that the assembler could catch some programming errors before the program was actually executed. Ito yung syntax error, diba, na ginagawa ng translator. Tinatranslate niya muna. Diba? So however, the symbolic notation still appeared at a bit arcane when compared with the notations of conventional mathematics. So to remedy this problem, John Backus, a programmer working for IBM, developed Fortran. So nag-develop siya ng kanyang language, Fortran, or short for Formula Translation Language. So that was in 1954. So programmers, many of whom were mathematicians, scientists, and engineers, could now use conventional algebraic notation, and Fortran programmers still entered their programs on a key punch machine, but the computer execute them after they were translated to machine code by a compiler. Yan. So sa bungya, wala na kita gagamit sang key punch machine. Automatic may kita ginatawag nga application software nga mag-compile sa aton nga written code. Yan. So Fortran was considered ideal for numerical and scientific applications. However, expressing the kind of data used in data processing in particular, textual information was difficult. So Fortran was not practical for processing information that includes people's names, address, social security numbers, and financial data of corporations and other institutions. But in early 1960s, a team led Rear Admiral Grace Murray Hopper developed COBOL, or Common Business Oriented Language, for data processing in the US government, and Usually, amo na yung first nga computer language, no? Ginagamit sa mga banks, the COBOL. Okay, ito yung ginagamit nila before sa mga ATMs, yan. COBOL programming language yung gamit nila. Ayan, ito yung example ng Fortran. Ito yung sinasabi ko na parang loto. Tapos yan yung pinapunch nila. Ayan. Ayan, parang loto lang. Di ba? Ito yung card nila na pang-punch. Ayan. So also in the late 1950s and early 1960s, John McCarthy, a computer scientist at MIT, developed a powerful and elegant notation called the Lisp, or list processing for short, or list processing pala, for expressing computations. Okay. Then a student of McCarthy's naman coded the first interpreter for Lisp, that was 1960s. And then in its early days, Lisp was used primarily for laboratory experiments in an area of research known as artificial intelligence, AI. So this was during 1950s, 1960s. May AI na. So ano na ngayon? 2022 na. Diba? Doon pa lang nila nakikilala si AI. Yan. More recently, Lisp have been touted as an ideal language for solving any difficult or complex problems. Okay. So these new high-level programming languages have one feature in common, which is abstraction. So anong abstraction? In science or any other area of inquiry, an abstraction allows human beings to reduce complex ideas or entities to simpler ones. Kumbaga, kung sa storybook, parang ano siya, parang synopsis ba yung tawag or summary? Parang summary siya. Yan. Para maging simple. So for example, a set of 10 assembly language instructions might be replaced with an equivalent algebraic expression that consists only 5 symbols in Fortran. Or put another way, anytime you can say more or with less, you are using an abstraction. So the use of abstraction is also found in other areas of computing, such as hardware design and information architecture. The complexities don't actually go away, but the abstractions hide them from view. So the suppression of distracting complexity with abstractions allows computer scientists to conceptualize, design, and build ever more sophisticated and complex systems. And so that's it for our class for today. Meron pa tayong more than 30 minutes. So I want you guys to answer your seat work number 1. Para sa those who have no account in LMS, so you may screenshot this one. Ayan. Your seat work number 1. So try to copy. So just answer briefly, the questions below in a piece of paper. Okay, so there are 8 items. I hope you can see. Nakikita nyo guys?
O sir,
Oo, sir.
Ayan. So screenshot nyo na lang or I might copy na lang this one. Send natin sa messenger. Stop sharing. Ayan. So sa mga wala pang account sa LMS, you may send your answers PM na lang sa Facebook. Okay, PM na lang sa Facebook. Wait. Wala akong internet. Wait. Wala akong messenger. Okay. So questions before we end our discussion? We will have another meeting for Physics 2. Okay, may harap pa? May concern, questions, clarification?
Why naman, sir?
If none, okay, so we can end our discussion. Stop recording.